Hello everyone. Can you hear me at the back? I think you can. So, how many of you went to see Interstellar last night? Hey, how many of you enjoyed it? Hey, okay, cool. I didn't get to see it because I was busy rehearsing my slides, so I'm one of the unfortunate ones who missed it. So basically, this talk is about, are your mobile users well connected? I'm not sure if you think they are or not, but maybe we can get into some discussion about that later. My name is Mandy Waite. I'm a developer advocate for Google. I work on the Google Cloud Platform. And my mission in life is to make the world or the cloud a better place for developers developing applications in the cloud. So usual hashtags. You can find me on Twitter @techgrrl, and Google DevOps is the hashtag, or just use the standard DevOps hashtags if you choose to. Okay, so our agenda today is basically to talk about why we really need to go mobile. This is kind of a little bit markety, but it's only like 3 slides, just to kind of position the whole talk. And then we're going to talk about, oh, hello, what happened there? That was interesting. It wasn't supposed to happen. How strange. I think one of my windows is closed. Maybe not. Okay, so then we're going to talk about building backends, particularly what's up with building backends. How many of you are developing for mobile today? And how many of you have a backend application, a backend component that, right, okay, so a lot of you are going to get this, and this may be interesting to you as well. So we're going to talk about Firebase today, specifically Firebase. The talk was going to be a little bit bigger, a little bit more encompassing when it comes to Google's technologies in the cloud, but we're going to talk specifically about Firebase. How many of you have heard of Firebase? How many of you are using Firebase? Okay, so not so many, which is good. I mean, if you'd all put your hands up, then this talk would almost be pointless. So most of you aren't using Firebase. Hopefully I can change that and get you to use it. And then we're going to look finally at where we're going, where Firebase are going, particularly with the announcement that Firebase have joined Google. They're now part of the Google team. So let's talk about the mobile market. Most of these statistics, I don't know where they get these statistics from. They're kind of strange, they're kind of corny. But apparently 2 billion people today have mobile devices. I have probably 10. And by 2020, again, apparently 80% of adults will have a smartphone. But not my dad. My dad will never have a smartphone. So he hasn't got one now. He won't have one in 2020. Mobile development started obviously on mobile devices, but gradually people have woken up to the fact that you can greatly enhance the experience of interaction with an application on a mobile device by having something else on the back end that allows users to share data with other users, to have a rich social experience, to do things like gaming, and also to do things like commerce, monetization of games, offering in-app payments in games and such like. Games? Yeah, whatever. And interestingly enough, on the Google Cloud Platform, again, how many of you have heard of Google Cloud Platform? I had to ask this question. Hey, well, that's pretty good. Okay. So the Google Cloud Platform, we have a big cloud platform, and over 50% of it is being used to power mobile applications. Now, we have some really, really big customers as well, so that kind of influences that. But it's interesting to note that 50% of our cloud platform is used to power mobile apps. Then we're looking at new business models, things like the ubiquitous nature of devices, also sensors, Internet of Things, that kind of thing. And a reference to that first statistic is at the bottom there. In terms of what Google's doing for mobile, we've obviously now have Firebase as part of our team, but we also have things like Google Cloud Messaging for Android. We have many, many public mobile APIs. We also have, you may have seen for Google I/O, we had this really impressive demo of Android for cars, which I'm not sure what the official name is, but Android in your car, which might be a bit worrying. Android for TV, we have wearables, we have phones. On the cloud side, when it comes to compute, we have things like App Engine, Google App Engine, Platform as a Service. We have virtual machines in the cloud, Compute Engine. And recently we've had this big move into containers. And we had announced last week a product called Container Engine, Google Container Engine, that allows you to effectively manage clusters, Kubernetes clusters. And we also have cloud endpoints. Oh no, on the data side, we also have, we have you covered there as well. We have NoSQL, Cloud Data Store. We have Cloud SQL, MySQL offering in the cloud. And for big data analytics, we have BigQuery. Then we have this thing called Cloud Endpoints. And really like to get into that more, but I'm not going to do that today, but maybe at some other time. Cloud Endpoints is interesting. It allows you to build APIs from back-end applications. Then we have this thing called Identity Toolkit. And again, this is something I'd like to cover in future talks, but we don't really talk much about it at the moment. But it's an authentication kit, allows you to authenticate with many, many different providers. So also on the business side of things, get this out of the way quickly, but monetization for analytics, we have AdMob, Google Analytics, and also Google Play Services. How many of you are developing for Android? Okay, all right, cool. So what's up with building backends? I'd like to probably ask, I'm not going to ask this question, but how many of you actually like having to develop backends and write backend server-side code? And I imagine it's probably not going to be many of you. You like it? Right, okay, cool. Okay, we should talk afterwards. Most people don't like it because building backends can be a little bit scary, really. You have an application you want to develop. You know what the application looks like. You know what features you want to include in it. It's going to run on a device such as this one, my Nexus 5. It's going to be, all of the application functionality is going to be encompassed in this. But you also want to provide that rich experience by providing backends that can allow users to share their experience across multiple devices and also to share it with other users. But having to build the darn thing is a little bit scary, having to write that server-side code. And also, the idea of having to maintain it. Maintaining it is even worse than having to build it in the first place. You have to have DevOps people. You have to have people actually managing this stuff. You can get away with using managed services such as platform as a service, managed data services, but you always have to have some level of maintenance. So building backends can be scary. And this is what I feel like whenever I kind of consider it. So why is this? Well, firstly, mobile is a little bit different from what we're used to, although more and more what we're used to is mobile. Obviously, you're familiar with the variable user interface constraints. We saw on the Google booth, we have a Nexus 9 with a 4:3 aspect ratio. We also have wearables. I've been lucky enough to have a Moto 360 for a while. I don't have one now because I don't really wear watches. I don't see why that's going to change. But we have a variable UI to write to effectively to build to. Devices are also personal. So my device here, I expect a high level of personalization. I expect this to be contextual. I expect it to be relevant to me. So when I interact with an application, I expect to see stuff that's relevant to me. It's also always on. It's always available. And also, networks, as you know, are unreliable. And my train journey from my house in the UK to the London office at Google, which I don't go to very often nowadays, I probably have coverage for about 20% of that journey. So networks are definitely unreliable. And for that, I need applications that will work offline. Obviously, sometimes you need to connect to the cloud to do stuff, to do Google search. You haven't got a local copy of the Google search data. So you need to be connected at times, but applications generally need to be able to work offline. So I've been playing Skyforce a lot recently on this. It's a great application. It shows me my friends' high scores, but when it's not connected, I expect it just to work. And also there are some challenges as well, and we kind of break them down into 4 main areas. So the first is the requirement to support multiple platforms and to get as much reuse as possible across those platforms, particularly when it comes to the back end. Really, we do not want to be able to have to write a back end for every single platform that we support. And then users, again, this is to a degree, depending on the type of application they're using, they expect to have updates in real time. So a chat application, for example, will be a perfect example of that, where you don't want to actually have to do something with the application to be able to see new messages. They'll automatically be pushed out to the application and you'll see them in real time. And also the fact that devices are sometimes connected because of network reliability and other reasons, like flight safe mode on a plane. It means we effectively have distributed state. We have some state on the client that's not been synchronized with the servers, and some state on the server that's not been synchronized with some of the clients. So effectively, we have state distributed across a large number of devices. And that large number of devices means we also need to have support for massive scale. And obviously, applications aren't always successful. They're not all Snapchat or Instagram, but you probably hope your application is going to be that popular. So these are the 4 main challenges. So when it comes to these challenges, we think that Firebase can help. We've already established that some of you have heard of Firebase, a few of you are using Firebase. So let's talk about how Firebase can actually help with this. This all sounds a little bit scary. And fortunately, while these problems are really hard, they're pretty consistent across every type of mobile application. So we always have this problem of managing state, multiple platforms, real-time data, and scale across every type of application. So, let's have a quick drink. So Firebase effectively came up with a very, very unique approach to addressing those 4 specific requirements. And so we're going to go into how that works. So firstly, let's talk about what Firebase is. Firebase is a real-time application platform, and it offers 3 main features. We're going to talk about 2 of them in this talk. One of them, the hosting side of it, we're not really going to cover at all. It's not really something I'm very familiar with. Obviously, I had experience with Firebase, or some limited experience with Firebase before they joined us, but since then I've been really ramping up, and they've been with us since October the 23rd. So I've not had a huge amount of time to spend on this. But basically, Firebase, the first area, is a real-time database that effectively allows you to store and share data directly from client-side code. And the next one is user management. And user management, Firebase effectively provides some kind of toolkit that allows you to manage user logins via authentication providers and add login effectively to your application. It also has a rules engine as well that can provide fine-grained access to data that you store in your Firebase. And again, I'd like to introduce the notion of a Firebase as being something that you have in the cloud that you store data to. So you have your own personal Firebase for your application. And hosting itself, just to kind of touch on it, hosting is for static websites. It allows you to tie your website to a domain name. It has full support for SSL. It has a CDN, and also it can be deployed, apparently, and I've not tried this, in one single command line. So mostly, really, we're going to be talking about how all of this stuff comes together to power the next generation of applications. And last week, these numbers are from last week. I think it's last week. Was it last week? I've been on the road for a while, so I have no idea what time is like. It's like being interstellar, like being dragged into the gravity well of a black hole. I have actually no idea what time of year it is. So what we talked about last week at Google Cloud Platform Live in San Francisco was that currently Firebase have 117,000 plus developers, probably in the order of 200 to 250,000 applications. And this year, a few months ago, they blogged about the fact that they hit 1 million current connections to their service. So 1 million connected client devices. Or maybe multiple applications on one device connecting multiple times. But interesting. So that shows that they can scale massively. And this kind of slide is just here to reassure you that you're not alone if you're using Firebase, or have some level of confidence that if you choose to use Firebase, you also are not alone. There are some large companies already using Firebase today. Companies like CBS, Citrix, also Nest, and somebody mentioned the Onion earlier. I'm not quite sure why the Onion is on there. Okay, so the next thing we want to talk about is actually how Firebase works. And some of this comes down to a massive shift in processing power that's happened gradually. Sometimes it's gone backwards and forwards. But there was a time when servers were really powerful and client devices were not. And all of the work would be done on the server side, and all the server would do would push down something that could be rendered very simply on a mobile device or any other kind of device. But that has changed, and very recently, I think last week, Jeff Atwood of Code and Horror actually posted a really, really interesting blog post, and that's the URL there, that shows his findings over the last few years from the time of the iPad 1, comparing the amount of time it runs to run a certain benchmark. And he's found that with the iPad Air Mini, iPad 2 Air Mini, I think, it's almost as powerful as his desktop machine. It can run this benchmark in almost the same time as his desktop. And so now we're looking at devices, again, mobile devices like the Nexus 5 here, that are extremely powerful. So now we have lots of processing power at our disposal on the client side. And storage hasn't grown so exponentially, but there's still quite a lot of storage space on these devices as well. So What that effectively allows us to do is to combine server-side processing with client-side processing to have a really rich experience, a developer experience. And with Firebase, they give you a client library that you include in your application. You effectively build your application around it. It's fairly simple to make calls to it. But it also does some work on the client side as well. So some client library applications, some client libraries, effectively just wrap an API and allow you to make calls to an API. The Firebase client library is much more powerful than that and does a lot more on the client side. Excuse me. So, synchronization. So the whole point of Firebase is to synchronize data from client devices to the cloud, to your Firebase, effectively. So when an application running on a client device that's hooked up to Firebase makes changes to data, that data will be instantaneously pushed out to Firebase, provided there's a connection, of course. It's written locally, well, instantaneously. Data is effectively written locally first, and then pushed out to Firebase on a best effort basis, based on the connectivity. So application response is immediate. The application writes data to a local store. All of the event triggers fire. The application can carry on doing what it's doing, because it believes that it's got rid of the data, that data has been stored. So, because going back to what we looked at before on the previous slide, because a lot of code is run on the client side and also a lot of code is run on the Firebase servers as well, it's very, very easy for Firebase to actually manage the application state for you. So we can also make data accessible offline as well. So the fact that we store locally means that we always have a local copy of data that we know about, data that we're interested in. So even when we go offline, we can still access that data. And that's really important. But Firebase really shines when we talk about collaboration, collaboration between multiple devices. And here, again, the same story, just multiplied many times, 3 times in the diagram, maybe several thousands of times, where data is being synchronized from a smart client, from some device, or from some web application to Firebase, and updates made in Firebase are being pushed out to clients that have registered an interest in that data. So also note from this diagram that Firebase supports multiple platforms out of the box. It supports iOS, it supports web, it supports Android. We also have Node.js, but there's also a Node.js client for it, which is generally used for the server-side stuff. If you want to access server-side state, Firebase state from the server side, you can use a Node.js library. And it also has a standard RESTful API and a streaming RESTful API. So what does Firebase actually look like when it comes to the database aspects? So Firebase is NoSQL at the back end. It stores JSON objects, nested JSON. And so that will be familiar to most of you. Most of you will be familiar with using NoSQL with JSON objects. Updates the whole idea of real-time. And I kind of had a bit of a problem with the term real-time initially, but I kind of get it now. We're pushing updates very, very quickly. So the updates that arrive from a client to a Firebase will be pushed out to other clients immediately, within milliseconds of arriving. And clients' applications don't actually have to do anything to get that data, apart from register an interest in it. It also provides a very rich security model that allows direct access from client devices to the data. So the security model effectively allows, it's rules-based, it effectively allows you to control access in a very fine-grained way to parts of your data. And, very, very interestingly, every single piece of data that's stored in Firebase maps to a URL. So you can actually access that, you can look at it in a browser, and we'll look at forwards later, or you can actually just use it as a RESTful call. So you can write your own applications that make RESTful calls to Firebase and access your data directly. We've also mentioned Firebase Authentication and user management already. So this is a bit more detail, and we'll look at one flow for this for GitHub later. At the moment, it supports email and password. They have their own mechanism for doing this. It also supports the most common OAuth providers, such as Google, Facebook, Twitter, and GitHub. And they have very, very simple mechanisms, and we're going to walk you through one of those shortly. And also, if you want to integrate with other authentication providers, maybe you have your own LDAP servers, maybe Windows Active Directory are the two that spring to mind. You can also use custom authentication tokens. So pretty much got you covered when it comes to user management. And this is good because the usual story for us when we talk about it is we had support for Google Plus sign-in or Google login. So this is much more extensive than that. So let's look at some examples of coding. I'm just going to walk you through these before showing you a quick demo. And this is really how simple it is to get up and running. This is Android code, so it's basic Java code. There's nothing Android-y really in this example. And the first thing we need to do is actually get a reference to our Firebase by making a call, creating a Firebase object with the name, the URL of our Firebase. So you just replace your Firebase with the name of your Firebase. And it's very, very easy to get up and running with a new Firebase. I can show you that shortly. So once you have a reference, you can do all sorts of things with it. Let's look at that. So the first thing is writing data, and this is really, really simple. So effectively, we have this JSON tree-like structure, and we can reference nodes, child nodes of a particular reference that we have. So in this case, we're referencing the child record 1 node of our Firebase. So effectively, this is one of the top level children. And we're effectively just setting its value to hello DevOps. And that's pretty much it. So again, the first thing that happens is this data is written locally, and Firebase, the Firebase client library, will effectively, I'm using that word effectively again a lot, will connect to Firebase on a best effort basis to synchronize that data with the servers. Then anybody who's registered an interest in that data, in record 1, will see those updates and be pushed out to them immediately. And this is what that would look like. In order to register an interest in data or to read a bit of data back that you just set, you would do this. So you would again use the reference, specify the child node you want to access, and you would add or register a new value event listener. And on your data change method, whenever that data changes, and the first time you actually call this, you will get the data back. So in this case, the onData change method will be called, and it will print out hello DevOps. And now, any subsequent updates to that data will also fire this callback. And that's simply all you have to do in order to register an interest in data. JavaScript looks very, very similar. And this is from the original deck we had. And I kept this in there really to show you that the coding paradigms are pretty much identical across all platforms. So this looks very, very similar to the code we just saw, where we're setting up a reference to a Firebase, we're calling set on a child node, in this case we're specifying that directly in the URL, and then we're also registering a callback handler to handle any changes. So it's exactly the same within JavaScript. I think I'm going to finish really quickly, so I'm going to take my time. So let's talk about authentication and also about offline operation, what we would call presence. So user authentication, we've already established that we support the 4 most popular providers, Google+, Facebook, Twitter, and GitHub. And the way this works, we have an example we're going to walk through now. This is pretty much the same flow for all 4 providers. You'll go to the provider, you'll create a new application or register a new application. So you'll go to this URL, github.com/settings/applications, and then they would ask you for a callback handler, and you would provide this URL with your Firebase name included in where it says your Firebase. And that's most of the work done. Now, in your code, you would create the Firebase reference, and then on that reference you would say auth with auth pop-up, GitHub being the provider, and you would have a callback handler that would effectively be the callback that was called by the authentication provider. All of the data related to that user, that logged in user successfully, would be stored in the auth data object. And you can get access to their email address, their name, whatever information is pushed back from the authentication provider. And so you can do all stuff based on that information. So we talked about offline quite a bit. We've already established that the network is unreliable, that the network tends to go away when it's most inconvenient. And often when we're on aircraft, and I seem to spend an awful lot of time on aircraft nowadays in airplane mode. And I still use my mobile device continuously while I'm on planes. So regardless of the fact I'm on airplane mode or flight safe mode, whatever they call it, I still expect to have some kind of capability within the application. One thing that's really kind of stands out with this with Firebase, and they do a great job of this because they have this local copy of the data. All of the event handlers are fired whenever new data is updated locally. The application can carry on being responsive and doing the stuff that it's supposed to do. But we also have this mechanism whereby you can actually detect whether a user is connected or not. So we have this special URL, which is firebase.com.info/connected, and effectively whether the user is online or not is stored in there. We also have this other variable that we've set up, which is a reference to some data, in this case, /presence/user ID. So this is a parameterized URL. And then we're going to register a function on our reference, which effectively will be updated whenever the user connects or disconnects from Firebase. And obviously, this method will only ever be called when we connect. So we're going to do some tricky stuff when we connect. We first check to verify that we are actually connecting, and then we call on our reference, we call onDisconnect.remove. This onDisconnect method is quite powerful and has many functions. One of them is the remove function, and it effectively means to, whenever I'm disconnected, whenever my status changes to disconnected, I want you to remove my presence. I want you to make it obvious to other users that I am no longer online. And we can also set the presence reference to true. This is again just setting some data. So effectively what we have in an application, such as a chat application that has a status next to people's names, your friends' names, maybe a green dot or some other indicator that shows they're online. And that makes that very easy to do with some kind of chat application. And many other applications do that kind of thing as well nowadays. So, quick demo of Firebase. This is where the fun begins, because the demo is going to be down there, and I'm going to be up here. So how many of you are familiar with web components and material design? Okay, a few of you, good, okay. So, not had a huge amount of time to get this demo ready, so we're using Polymer, we're using a web application instead of a mobile application. We are determined, myself and Ray, my colleague here, who are going to give this talk several times over the next month or so, are determined to fix that and have an Android version of this application at some point. At the moment, we had to make do with a web version, but pretty much all we're going to talk about today, as we've seen, because things look very similar as we move from platform to platform, you'll see that it's very easy to build the same thing within Android or other supported platforms. So this is our a card application, effectively. Allows us to create cards and delete cards. And this is static data. This is a file called API.json, right? API.json contains some static content that we read in. And the code for that looks something like this. I'm going to have to drag my window over. So what we're going to show you here is the code for that application, but we're going to show you the very simple changes we need to use a different data provider, as opposed to all of the changes we need to make to iterate over the data in a slightly different way. Those changes are kind of unrelated to what we're doing here. They're important, but they're not really core to what we're talking about. So here we're using Ajax effectively, and this is Polymer. This is a kind of DSL for writing JavaScript HTML5 applications. And effectively, we're using Ajax here. We have our handlers, and we have this thing called non-core response, and we also have our data set, which in this case is API post.json. It's a static file. So what we're going to do is replace that with calls to Firebase. And the code for the Firebase stuff is at the bottom there. Well, sorry, it's commented out currently. So we're going to use that and use a different version of the application. So let's go to that. And so we have this already running. We have this running locally with a proxy. And we have 3 cards in it. Now, it doesn't look a huge amount different from what we had before, right? So what happens when we actually do something here? So let's make sure I'm in the right one. They look so similar. Okay, so Ray. Awesome demo? Right, okay, so it is an awesome demo. We can put that in there. Oh, we got 2 of them already. I should delete one of those, shouldn't I? But I won't. What I'll do first, I'll go here into Forge. And Forge is the graphical debugger for Firebase. And it provides us with a real-time view of our data. And it's really, really cool. So at the moment, we have 4 records. We have 4 cards. And all of these records are pretty much the same, apart from the data themselves. So we have an avatar, we have favorite, we have text, and we have username. The avatar is just a path to a local file. And that's all well and good. But what happens if we add a new one? What happens in Forge? So let's just collapse these. I thought I had a collapse all button. I do. So I'm going to add a new card to our data. Find the button. It's really hard to do this like this. Okay. Oh, no, what did I do? Oh, help. I have to work out which one that was then. Which one are we running? That's 8,000. Don't do that. Oh, I don't want to do demo. Maybe I've shut down the server. Bear with me a second. The world of live demos. I've been cursed recently. I did a demo in New York in the Google office, and I took this thing called Totoro. He's a Japanese anime character, and I said he would bring me luck for the demos. He would kind of appease the demo gods. But unfortunately, that didn't happen, and my demo broke. And so I left him at home since then, but ever since then, my demos have been breaking. So let's run this again. That's 8,000, and that's 8,001. So we have the first one running. Yeah, but that's not what I want. No, this should just work. Hold on. Why is it not working, Ray? Maybe I've moved, maybe I've changed directories, but I don't think I have. I think I ran it in the background. Oh, I have. Ah, okay. I'm in the wrong directory. Okay. Right, okay, so now we're back. So this wouldn't have happened with the other application if we'd crashed it and restarted it. We wouldn't obviously have seen the data that was stored in Firebase. We would have seen the original data that was stored in the APIs.json file. But here we have 4 cards, and we're going to add a new card here. And this will be, say, and it is, right? Interstellar is a great movie. So we add that card. And we can go back into our Firebase now, and we can see that we have a new card. Interstellar is a great movie. So that's now stored in Firebase. So now we only have one client, but if we have multiple clients connected to this application and had an interest in that data, they would see this update. So if they were running a version of the card application on their mobile or on their web client, they would see these updates being pushed to their application immediately. Now, how the user interface handles those events is up to the user interface, but the data is immediately available to be used by the application. And one thing we can do, if we just move this into a separate window, this is where it gets dangerous. Well, it's already been dangerous, so let's not worry about it too much. If we basically say, we really like the fact that I'm demonstrating how amazing Firebase is, we can just click that there, and we will see the update pushed out immediately to our Firebase in Forge. So now that's true. And that was pushed out immediately. We actually saw that happen within the user interface within Forge. And we could actually change that value ourselves. and that would change the status of the like within the card application. So that's how it works. So instantaneously, updates from the application are pushed out to Firebase. We can see those updates in the Forge debugger, and any clients that have an interest in that data will also see those changes at work as well immediately, providing they're connected. If they're not connected, they'll get those updates as soon as they do connect. So, right, okay, sorry about the demo, that broke a little bit. Back to the slides. So if you're interested in that demo, the card demo, the Polymer project demo is available there. It's effectively a tutorial. It has 4 steps that go through the process of building an application. The information about actually changing it to use Firebase, we can look to see if we can publish it once we go forward with developing the application a little bit. At the moment, it's a little bit weak on functionality. There's some stuff we actually have to add to it, but at some point we will publish that. And by the time we give this talk next time, or maybe, we hopefully will have an Android client for it that we can use as well. So we've talked about Firebase and how good it is and how useful it is. How do you get started? Well, it's really, really very simple. You go to firebase.com. There's a tutorial. There's also a free tier as well. I think we should probably go there and have a look. So this is Firebase. We can log in. It has this annoying habit of asking you to log in every time you change from one view to another. I have a couple of applications that I've created for free. I have a DevOps demo, the one we've been using, and also my first application, because you always have to have my first application, right? And it has 5-minute tutorials for different platforms. It also has quick start guides for different platforms as well. So if you're interested in web development or Android development or iOS or using the REST API, then you can go straight to that. It also has good explanations on security and rules, which, as we mentioned, are declarative, written in a DSL that's based on JSON. And rules can also be accessed from Forge by going to security and rules. And you'll see that your Firebase has a default set of rules. At the moment, we don't have any kind of authentication enabled for this. Very, very easy to set up. But once you've enabled authentication, you need to effectively provide authorization as well. So you're going to say which users or what capabilities do people have when they're accessing this data? Can they read it? Can they write it? Do they have to be authenticated to be able to read it or write it? And you can provide access, make it so that users only have access to their own data and not access to somebody else's. And it's very, very simple to do. And pretty much all the configuration within Firebase will be done through these kind of rules. And we'll look at something else shortly that kind of bears that out. So it's very easy to get started with Firebase. And it's really easy to just kick the tires with it and play with it and see the kind of thing that we've seen today. When it comes to going forward, obviously, we talked about Firebase have joined Google. They became part of Google on October the 23rd. And they're just moving offices this week, so they have a lot to do. And let's talk about what's next for Firebase. I'm really kind of only interested in the bottom line here, but they have recently announced support for richer queries. I have not really looked into that in much detail. They also have some parts on different platforms of their offline support to not be complete. So they're looking actually to beef that up. And Firebase have, in the past, always worked on the basis that they will develop something until it's right, and then they will start talking about it. So originally when Firebase was released, it was already working. It was ready to go. It was ready effectively to be in beta or beta. And when they announced the security rules, they'd already done all of the work ahead of time to make that work. They'd opened it up to a few beta testers and such like, but it was effectively released as a fully working function, a fully working feature. They're also going to provide improved management and analytics. And one thing they're going to look at is integration with the Google Cloud Platform. Really, that's in order to be able to leverage the power of Google Cloud Platform, virtual machines, platform as a service, the storage services, that kind of thing. And one thing they talked about at Google Cloud Platform Live last week was this thing called triggers. Now, on the left-hand side of this diagram, we have a mobile device talking to our Firebase, syncing data to and from the device. That's pretty standard. We've seen that all covered completely. But what we can do is also declaratively register triggers. This isn't available yet, it will be soon. Register triggers, and these triggers will effectively say when they're like value listeners. So when the data changes in some way, you will fire a trigger. And a trigger is effectively a call to a webhook. So it's a parameterized URL. Every time that data changes, that webhook will be fired. Information about the change will be included in the webhook. Then, all you need to do is write an application that can actually service that webhook. Now, it could be anything. It could be a web application run on Apache with some server-side logic, maybe running Passenger, that kind of thing. It could be Google App Engine. It could be Heroku. It could be anything that's handling those requests effectively. So when a trigger fires, parameterized URL call with all the information about what's changed is fired out to a different service. In this case, in this example, we're effectively, this is tied to a sample application. They're effectively generating reports on the data changes. So we have the data that's been changed. We push it out to App Engine, which is our endpoint handler. This is effectively handling the webhooks. And App Engine then does some processing on the data and stores it into a tool called BigQuery. How many of you have heard of BigQuery? That's getting better. We're winning. BigQuery is fantastic. BigQuery effectively allows you to run analysis across very, very large data sets, or very small ones. I mean, it can work across all of them. But it allows you to effectively run queries across very large data sets in order of seconds, not minutes or hours, as you would expect with a MapReduce. It also allows you to do interactive analysis of data as well. So you can actually sit there at a console and run SQL-like queries to ask questions of the data. So in this case, what we're doing effectively is doing analytics. Where every time the data is changed in Firebase, a trigger is fired, App Engine does some processing, and the data is pushed out into BigQuery. All of this is via RESTful APIs. And a trigger, again, another DSL, will look ultimately something like this. It's not really clear exactly what that's going to be, but we're basically saying, for some set of data, I want you to fire off this webhook, which is a post request to this endpoint with this body. And it could be probably a GET request with a parameterized URL as well. And also, that we would also include information about the data changes, the actual changes that were made to the data. So that's Firebase. If you want to know more, there's really only one call to action, and that's to go to www.firebase.com, have a look around, get started maybe. Again, it's completely free to use initially, and get started and build an application. And with that, with 18 minutes to go, I'd like to thank you all for coming on a Friday morning after watching Interstellar late last night, and hopefully really enjoying it. And do you have any questions? Right, hello.
You showed two-way sync before, where you edited data in Forge, and then almost immediately saw the favorite icon change.
Yep.
How is it implemented on the client side? Is it event-driven?
Yeah, so... Yeah, so what will happen is effectively the application will interact with the client library, making calls into the client library. The client library will say, I have data that's changed. I will write that locally to my local data store. At some point, once we're connected immediately, it will be fired off immediately. That updated data will be fired off to Firebase, and that data will be updated in real time. That's how it works.
And then the local database notifies the client code.
So the local database notifies, yes. So the question is, once the data has been updated, does Firebase effectively fire off the event triggers to say that this data has been processed? Yes, for all intents and purposes, once the code has been written to Firebase locally, events will be fired to say to the application, yeah, we're done. It's effectively like you've written it to the database, everything is done, you're happy. And the application will continue on as before. It won't block regardless of whether the device is connected or not connected. Okay? Brilliant. Any more questions? Hey. Right, so the question is, how does it handle conflicting rights from different clients? Okay, so I don't have all of the details of this yet. Maybe one day I will. Whether we'll be able to share it externally or not, I don't know. I do know this, though, that before they released Firebase, they spent a huge amount of time working on race conditions. They're working on conditions exactly as you described, trying to eliminate them. And they have done an amazing job. They talk about transactions, so it is transactional. I don't know the details behind the transactions, but at the moment, it works extremely well. And I'd be interested to know if they actually have any kind of guarantees in terms of concurrency, but it does seem to work perfectly. So I can't give you much more assurance than that. Does that help? Any more questions? Hey. Sorry, I'm just trying to check to see if there's anybody I'm missing.
There's a beautiful sync between your Android app and the remote Firebase, or between your web application Firebase. How about other platforms like iOS or even worse?
Yeah, so Firebase supports out-of-the-box. Really what you're interested in is client libraries, the ability to actually have that Firebase code, because this is no longer a wrapper around a RESTful API, so you need the client library. You can make RESTful calls to Firebase to actually query the data, but to get the full effect of the pushes from Firebase, you need to have this client library. So the client library support is for web currently, iOS, and Android. So we have those 3 platforms supported. But it does have a RESTful API. There is also a Node.js library, which is effectively used for server-side code, but does the same thing effectively as the clients. So it's very much the same as what the clients do, but it's just for writing server-side code. Hey.
Possible to use the client library without the server backend?
To use the client library, well, yeah, I guess so. I mean, I'm not sure why you would do. Is there any particular reason you're thinking? So the question was, is it possible to use the client library without actually having to worry about the back end? Is there any particular reason why you would want to do that? Or just a kind of, you're just thinking about?
I'm looking for a client library to store data on mobile devices.
Okay, yeah.
I have a really fixed backend I can't change.
Right, okay.
I'm not responsible for this.
Yeah, I think it could work, but I don't think it would be particularly helpful to you. There must be better ways of writing a data store, something that will store data on a mobile. But it could potentially work for you. But yeah, probably a bit of an overhead. Any more questions? Hey. Can you run it on your server? Run Firebase, you mean? No. So Firebase is a service. So it's effectively a software as a service or a database as a service. You can run, obviously, the application libraries, such as the Node.js library we've already talked. Sorry, the question was, can he run it on his own servers? So no, Firebase is based in the cloud, will only run in the cloud. It's not available for private clouds currently. Obviously, you can make calls out from private clouds to Firebase, but there isn't a way of encapsulating Firebase internally within, say, a corporate VPN. You would always have to make calls out to it. Okay, any more questions? Hey. I'm sorry? Can cache be encrypted? Ah, that's a good question. Why would you? But again, it's on your device. But it depends. You don't know where data is going to be stored effectively. So maybe if you're using a set-top box or something like that, you may want to encrypt the data. I don't know. I don't know the answer to that. I can try and find out, but it's a good question. So the question was, is data, or can data be, the data that's stored locally on the device, can it be encrypted? And the answer seems to be, I don't know. But it would be interesting to find out. Hey.
Rails dev doing backend stuff.
Uh-huh.
Do you anticipate support for Ruby or other server-side languages for Firebase interface?
Absolutely, yeah, I would imagine so. I mean, Node.js is an obvious low-hanging fruit for starting off for that server-side stuff. You're talking about Rails clients or the server-side? Right, okay, so yeah, I would imagine it would not be difficult to do that. Obviously, again, we have this kind of complicated logic that does some caching locally, so that would have to be written, but I can't see any reason why they wouldn't do that. They probably have a prioritized list of things they want to support, though, so I'm not sure where Ruby and Ruby on Rails would be, but it seems definitely possible. Maybe it's something you could, if you look at Firebase and ask questions of the devs, maybe you can suggest it to them. Yeah, okay.
Firebase site says that there is an on-premise installation capability.
Oh, is there? Oh, okay. So the question, it wasn't a question, it was actually a statement saying Firebase say there is an on-presence option. So on-premise, an on-premise option, which is interesting. I didn't know about that. Okay. Thank you for the information. Any more questions? Hey. Oh. Yeah.
It sounds like an excellent way to choose the battery. Is it just maintaining a socket, or are they porting it out to like PCM or DNS?
I don't know the exact details. So the question is, how does the client effectively interface with the server? Does it use long polls? Does it use... it doesn't use polling of any kind. In the context of the presentation that they gave last week at GCP Live, they basically made a big point or a big deal about the fact that this wasn't heavy on battery. So they must be doing something really funky underneath the covers to actually prevent having to have this kind of long polling type thing going on. So I don't know the details. I think we'll find out more about that as we get more involved with them. Maybe one day I'll be able to answer those kind of questions. At the moment, I don't have the answers, unfortunately. Hey. Sorry.
If on the server the rules about permissions change, will it affect the data of the client?
No. The data stored in the client is just the data stored in the client. I know what you mean, though. You're saying basically the client has effectively a local view of the data within the Firebase. At some point, once the rules change, that data will be synchronized back. And what will happen when it tries to synchronize the data will be based on the rules. So I guess at that point, things will change and things will break. It's an interesting question. Hey, Ray, could you take a note of that? I'd have to look into what happens, but it's a really, really good question. Effectively, what happens if the client is modifying data in a certain way, has a local version of that data, and then we change the rules on what data it can actually update. So when it pushes these changes out, it may no longer have permission to actually write that data. What happens then? It's a really good question. I don't know the answer to, but we can find out for you. Any other questions? Hey. Can you query? Yeah, so I don't know much about the details. Again, I'm running into my lack of knowledge now. So we had this thing called Rich Queries that they announced last week. Effectively on the 4th of November, they announced Rich Queries. So you have the ability to do queries across Firebase, but I don't have the details. But definitely look on the website and they'll have more details. I actually tried to find out details of where these queries were last night and I couldn't find them. So I apologize for not knowing more. Any more questions? Hey. Can you shout a bit louder? An old version of the data? I wouldn't think so, no. You're talking about some kind of revision history or some kind of audit trail. Yeah. It depends on the way Firebase is actually structured, whether that would be possible and whether they would allow it. But I've not seen anything in the documentation so far that would suggest that you could do. So the answer to the question was effectively, can you access old versions of the data? And I would say the answer would be no. Any more questions? Okay, well, thank you very much. Thanks for coming today. Enjoy the rest of your day.